everyone. Welcome to our ZipChat today. So this is episode 5. We have started this kind of at the beginning of COVID. We started having this more casual webinar just to kind of be a little more interactive. And I'd like to introduce our host is Mike Watson. He is our VP of Engineering at CenterZip. Mike, over to you.
Thanks, Jill. Hi, everyone. I'm Mike Watson, as Jill mentioned, VP of Engineering at CenterZip. I'd like to welcome you to our latest rendition of ZipChat. It's episode number 5. Is Service Mesh ready for prime time? Hopefully, by the end of this ZipChat, we will answer that question, or at least get somewhat of an answer to that question. I want to let everyone know that we do have a white paper on Service Mesh. It's called Emergence of Service Mesh and Cloud Native Architectures. It's available on centerzip.com, or you can download it as a handout right here on the ZipChat webinar. So feel free to do that if you'd like now or whenever you're ready. With me today, I have Bruce Matthews, Senior Solutions Architect at Emergence. And I'm happy to have him on. We've had a nice chat in the green room about common experiences. One of the things that I realized is when I was first coming out of college, I worked on a project that essentially was an archaic version of a service mesh. We built it out of necessity. It was a big project that had multiple commercial off-the-shelf solutions with it, and we had to figure out a way to get these systems to talk to each other to support the business. That was way back in 2002, working at Boeing. So that was, it's bringing back a lot of fond memories and making me realize that the more things change, the more they stay the same. Like, these good architectures are still good architectures, and technology just makes them even better. So with that, I'd like to bring up a poll, and while we're voting or you're selecting your choices, Bruce, why don't you introduce yourself real quick?
Yeah, so hi guys, I'm Bruce Matthews. I've been in the computer industry for about 43 years. Really do enjoy learning about new technologies. I think that's the reason I haven't gone crazy over the 43 years is I'm still a student of things. And for the last 3 years, I've been focused on the Kubernetes framework as a infrastructure as a service provisioner and service meshing as a adjunct to that, which really does extend the framework.
Awesome. Do we have the results of the poll, Jill?
Sure do.
Awesome. So it looks like about 50% of y'all are have providers, and the other 50% are not using a service mesh. Not too surprising.
No.
Service mesh, sometimes may seem like a little bit of a luxury item. So actually, let's just dive into that thought. Bruce, what is your thought about service mesh as a luxury item, or is there some use cases where maybe service mesh really should be in your solution?
Yeah, so I think fundamentally for a lot of people who are transitioning from a traditional architecture to a more cloud native architecture, you're going to need to have something that fills the PaaS gap, and that the service mesh really exposes to your containerized community all of the things that they used to have to create for themselves or to have them provided as PaaS. I don't know how much depth you wanted to go into in terms of the architecture itself currently, but it basically splits into 2 aspects for a sidecar architecture of a service mesh. And the first is the control area, and the second is the data area. And they've separated those out specifically so that needs in terms of most corporate entities using it. And it provides a very rich layer of services that you don't normally get.
Yeah, great. Moving on from there, so I was thinking about this. It's like, why isn't just using Kubernetes alone, or your whatever container solution, why isn't that not sufficient for this type of activity?
So one of the things actually that's kind of unique about the Kubernetes framework itself was instead of simply hard coding all of the services that were required to fill networking gaps and to fill storage gaps and to fill other control services, the Kubernetes framework itself relies on the creation of plugins. So there's a CNI plugin for all the networking interfaces. That means you don't need to simply rely on Calico as the only networking capability you have. You could plug in Flannel. You could plug in even OVS from OpenStack as a provider of networking. Same thing with storage, that the persistent volume mechanism has been created as a plugin, and as such, that allows you to select from a variety. This has an advantage and a disadvantage in that it makes it more flexible for you to pick the right ones to satisfy your workloads, but it also makes it more complex to manage and maintain.
So I was just thinking about the sidecar architecture. I'm going to dive into that a little bit.
Okay.
With that, is there an additional, like if you're using a cloud provider, which most of us probably are, is there additional cost to having that sidecar, or is it minimal? Like how does that affect your cost scheduling?
Well, if you think about it, the sidecar architecture is actually a mirror container. So for every single container you create that requires redirection for the networking part of it, and the services associated to it, you're going to have a second container. If they both require persistent storage, they both require network throughput, it's going to, in terms of a cloud provider, it will double the cost of whatever you've allocated. So in GKS, it would be roughly 2 to 1. Same with EKS, AKS. If you're going to do it yourself and just use virtual machines and then lay down your own Kubernetes, lay down your own sidecar framework like Istio, it's the cost of whatever that VM is, which is kind of a way of cutting the corner.
I see what you're saying. So if cost is an issue, you may want to just use the infrastructure at kind of more bare bones level.
Yeah.
Build up on top of it yourself so that you can gain the benefits without increasing the price too much.
Yes.
So what about the cloud providers' offerings? I mean, is it competitively priced, or is it going to be 2 to 1, or is that what you were referring to?
Yeah, it's pretty competitively priced, I would say. I believe that the benefit really comes from the flexibility of building your own, so that you can choose which one of the CNIs you want to use, the CSIs you want to use, and the commercial offerings from cloud providers will have picked one for you.
I gotcha. So just as a reminder, we do encourage audience participation. So if you do have a question, you can type your interest in the question. And we actually, unlike our webinar series, we encourage you to vocalize your question. So we'll unmute you, you can chat with us, and we can have a small interaction if you're interested. So don't hesitate to do that. This is intended to be a casual chat. Bruce and I are just kind of going off the cuff a little bit here. And, if you have any questions, I mean, Bruce really knows his stuff here, so good source of information. Yeah, so I was thinking about that experience I had way in the past, and it was actually triggering some interesting thought patterns. So what features do you think are the most critical in a service mesh? Like, how does it break down? Because I know when we were working on that system, all of our services came out of need, right? So at first we had one pipe between one system and the other, and we realized that didn't scale, so we had to do some sort of load balancing and spreading things out.
Right.
ultimately had to break down transactions into small bits, which looks a lot like a microservice stack. So, I mean, this all just kind of came as we were building out this system way back when.
Right.
So what are the key features? What do you need to be looking for?
Well, so as you point out, all things old become new again when they're faced with a new architectural design to implement them in. And you're quite right in pointing out that the service mesh that you created satisfied need individually. There are about 7 different aspects of features and capabilities that are included in almost all of the service meshes that are out there. But there are 2 that are kind of the foundation for it. And the first is the ability to provide a catalog to your containers. So it exposes all of the features that it has available, like load balancing, like TLS endpoint security, like in general encryption, authentication, and things like circuit breaker patterning. But the foundation is to be able to expose them to your containers without having to program them in, so that they are just part of the service delivery catalog that is available when the container is implemented in a pod. So that's really the first critical feature. And then the second most important feature to me is the service level visualization. That realistically, you have to be able. Hello. Yes. You have to be able to sort of capture what's going on in the flow of data from one datagram input to the datagram output from a container, and to see what happened in that traversal, and to be able to understand then how a particular segment is being blocked, so that you can remove that impediment and make your data flow between containers and out to the real world and in from the real world in a way that enhances the end user experience. That traffic shaping is really what a service mesh provides.
Gotcha. Yeah,
It might
again,
be a good time to bring up poll number 2, which are some of the features of service mesh.
yeah, let's do that.
Okay. I'll launch it while you guys still talk. And so here I'm going to share the results of this poll.
Yeah, thanks, Jill.
Oh,
So circuit breaker pattern seems to be the clear winner here.
yeah.
So why don't you dive into that a little more, Bruce? What, just for those of us that may not be as familiar with circuit breaker, how does that work?
And it's one of the better developed features within it. It really allows the developer to make decisions about what to do when something breaks in your environment. If you have a 3-level load balanced workflow that has to go from one set of front end to a back end to get the individual result of what the application calls for, it will actually allow you to say, if you get to V1 version of the load balanced instance, stop. Don't go any further, because the V1 version has a flaw in it that will prevent it from, it would cause a cascading failure, for example, in the back end. So stop at V1, but go through V2 and V3. This is like for a developer gold, right? Because now you don't have to rely on programming that in each time. It is in the ingress, the gateway, that satisfies the end result back out to the customer. It never has to hit any of the containers inside. It just knows what it's supposed to do if that's broken.
I see.
Makes sense?
And with the control plane, as I understand it, would that be configurable on the fly? So
Yes.
you can change these rules, in somewhat in real time, or at least in some level of configuration time. Versus the worst case that we had is we had to build all of our configuration into our system,
Right.
just because of the nature of the technologies we were using in those days. So we wanted to make that adjustment that we had to roll code.
Right. Which this saves a whole lot of time because you can just adjust the configuration to satisfy that demand.
Yeah, so I think with the sidecar and introducing that service plan, I mean that's pretty nice. Allows you to do a lot through managing through a console versus redeploying code and all the complexities, even redeploying configuration, which is, I think, if I were to guess, most people will do their configuration through hard-coded scripts that they manually adjust and push those configurations because they don't change very often. But for these types of situations, you may want to be able to change them frequently.
Well, now instead of rolling code once every 6 months, like maybe we did with C code and things like that, now we're doing 2,000 times a day to make improvements. So
yeah, that's a lot easier in the modern world. Just briefly, this all sort of assumes that there's a microservices architecture, right? Like if you don't have one, it doesn't seem like it would have as much benefit. Is that true?
Yeah, I think that it's become more granular. It allows you to select which pieces of the architecture you're changing on a much more granular level to improve the performance of individuals, independent components, whereas most applications were written as a monolith and you have to change the whole thing. This allows you to go in and selectively target more like a pinpoint than a blast. Also, and I think that this is kind of a key to the whole thing, these clusters of infrastructure capabilities can be expanded on the fly. You don't have to, live with the way the scale has been set up. You can provide auto scaling and redistribution of workload within, for example, a Kubernetes infrastructure, and the service mesh will just accommodate. It will create more of the sidecars that are necessary to satisfy the need. Mm-hmm. And then finally, and this is, I think, the critical aspect of management and maintenance and all of those things. If you think about it, in a sidecar architecture, the blast radius is only one container. If I lose a sidecar, I only lost that one container, and there's another one providing that same level of service somewhere else. Mm-hmm. So,
yeah, that is nice to have that sort of fault tolerance built into it. So I think, Jill, do you want to go to another poll?
Sure, we do have one more. Let me launch it. And so for those of you who are using a service mesh, what type of service mesh are you using? From my understanding, there is some open source and some commercial ones.
Yeah, this is going to be of great interest to me as well.
So we were talking about this ahead of time. You were talking about this concept of containerless programming, or I don't remember exactly what you called it, but I thought it was interesting and a little confusing. So do you want to shed some light on what you're thinking there?
So here's a really interesting next phase of our development as a cloud native architecture. Look, we've seen, we started with bare metal provisioning, and it was pretty easy to know what broke. It was the machine that went down, and all of those kind of things. And then we wanted to take greater advantage of physical hardware. So we moved on to virtualization and, split things up into virtual machines, and those, maybe you could host 20 on a physical piece of hardware, depending on the number of cores and things you were dealing with. In the next generation, we decided to containerize things. And that's a really cool step that we've taken. But they began to realize, and this is the event-driven processing that's come about, that they call serverless architecture. This next generation could actually be containerless. Why do you need the container running until you need it in the application service? So you have a registry, a catalog of all of the containers that you're possibly going to use. They're registered to you, they're notarized so that only your people can have access to them. You've created a neural network based on a service mesh that understands the sequence of events that need to happen to satisfy a workload. And you've described that then as a neural set of appointments that can be differentiated dependent on the input having been changed to the output. It then knows where it needs to go to get the next piece because it aligned with a specific input. So why do you have to have the container running until it's necessary? The only reason is really because we haven't all decided that the framework is going to be the same, and all of that kind of thing. But if we all decided that Kubernetes was the framework, for example, we could then have that container spin up only when it was needed, take the input datagram, massage it. If nothing happened to it and it came back, I was done with the process. If something happened to it, it changed. Now I know I need to go to the next step, and that's where the neural network comes in. So anyway, and that's what I call containerless, is that it's really containers, but it's containers only when they're needed. Thanks.
Yeah,
I probably went on about that a little too long, but.
No, it's quite all right. Let's look at the poll results. Little birdie told me that I forgot to bring that up, so let's talk about it now.
Wow.
So it looks like just two choices here, which is interesting information. Istio is definitely one I've heard of, and gray matter actually just came to my attention today. It was not in my research. So what do you think about gray matter?
So this is kind of cool because I've had experience with both of them. And I've had the pleasure of having the people who were the developers, original developers, provide me demonstrations and talk through the capabilities and features of both of those, both the Istio frameworks and the gray matter group. Gray matter is actually more a service mesh of service meshes. So it provides the ability to integrate multiple types of service meshes within the same framework. You can manage and control all of them from a centralized source. And in that way, you may not need to make the decision of just using Istio or just using Console or just using, one of the Envoy. You can piece together multiple frameworks, multiple service meshes to satisfy your framework. Very robust, very feature rich, and is building into it more and more features each day. Istio is on an accelerated path to just be a Kubernetes service mesh. And that, I think, is kind of key if you're going to stay in the realm of the Kubernetes framework. But if you have workloads that go beyond that start to take advantage of serverless, that start to take advantage of bare metal in your environment, and you need to manage all of the mesh that brings all of them together, gray matter might be a really good choice for that.
Gotcha. Yeah, so it really just depends on, like with the cloud providers, I'm guessing, if you're all in on the cloud provider, you might as well use that solution. And so if you're all in on Kubernetes, you might as well use a solution that's highly attuned to it.
Right.
That does definitely make sense to me.
Yeah,
So go ahead, Bruce. You're going to say something.
I was just going to point out one of the advantages of using a cloud provider's service mesh offering is that they offer serverless functions built into it. That's the positive side. They're already there. You don't have to develop them. You don't have to, write more code, except for the things that you need to use. The downside of that is they've written their own functions.
Yeah.
So it means that you can't take it and move it from one cloud provider to the next, because cloud provider A and cloud provider B have two different function sets.
And the mesh can't cross boundaries of like in a hybrid cloud type of situation.
Right.
Yeah, so that would be a good use case for not using the cloud provider version, is if you need hybrid capabilities,
right,
or you're connecting multiple, systems that are coming from multiple sources. Yeah, that also makes sense to me. Yeah. Mm-hmm. So Jill, is there any questions from the audience? I think you pinged me and said there's at least one, right?
Well, when people register for the webinar, I give them an opportunity to ask a question ahead of time. And I did have one person do that. And they were just asking about the feasibility of various upgrade models, such as blue, green, canary, rolling, etc., using service mesh.
Mm-hmm.
That's a good question.
Yeah, it is a very good question, and I think it's an essential part of the maintenance of these things. We don't just want to implement them, we want to maintain them over time. And building in Canary, building in Claire as the drop-in for application code upgrades is kind of an essential piece of it. Not to have a Mirantis commercial here, but the universal control plane that creates a Kubernetes cluster in your environment and installs Istio as the framework for the service meshing provides that canary-oriented framework for each one of its upgrades. It will go through automated coordinate train of each one of the worker nodes involved in delivery of a service. And it will try, at least as best it can, to reorganize things so you never lose service while you're upgrading, which is a unique feature of what Mirantis offers. But that's my company.
You're allowed to have a small plug-in there. So Jill, any other questions coming from the audience? We want to give people a couple of minutes. Maybe we can show our contact information in case y'all want to get in touch with us directly.
We do have one quick question that's just come in.
Great.
Let me unmute this gentleman. Just 1 second. Okay, Rohit, if you can go ahead and ask your question, that would be great.
Sure, thanks. So my question was around, you also mentioned about different cloud providers, which kind of baked in their own service mesh, right? Like AWS has their own service mesh based on Envoy, but GK also have it, and then we also have a hybrid solution. But when we're trying to run, let's say, services across the public and the private cloud, how do we manage, let's say, configurations? It could be, let's say, my service mesh configurations on retries, Canary, same application deployed on different platforms, but then how do we try to manage them, upgrade them, roll them out? Like, what would be your best practices, or what would be your recommendation on that?
So do you want to talk about that at all, Mike, or should I?
Oh yeah, why don't you take that one, Bruce? I think this is right up your alley.
All right. So from an upgrade update standpoint, you are always going to be better dealing with something that you deploy yourself, that you have the ability to manage and maintain, rather than taking advantage of the prepackaged versions of service meshing. For example, AWS's mesh is really Envoy packaged with some of Istio. For my money, I would suggest that if you decided to take advantage of Envoy as your proxy service, which I highly recommend because it's the fastest one out there for the purpose, that you would then take advantage of the open source Istio as the foundation for the service mesh framework that could extend from where you are through the VPC to, and here's the big point, then take advantage of don't take advantage of AKS and GKE and the EKS packaged versions of Kubernetes. Take advantage of their virtual machine services and build your Kubernetes on top of those. Cluster API allows you to manage across all of them using the same methodology because they're standardized. Each one of the vendors has built their own that massages that and manages how the clusters go together, which make them unique and make it more difficult to manage across them. That's done intentionally. They like to make money. This will give you the ability to manage them yourself and provide the service. Now, you have to know more about the Kubernetes framework. You have to know more about service meshing to be able to do that. But when you've taken that on and developed that expertise, you will be able to then upgrade, update across platforms without any problems.
All right, hopefully that answers your question, Rohit.
I do have another question from another audience member.
Will service mesh be used to support staging of containers in shared environments during development/integration testing and prior to development or deployment? Sorry.
Yeah, typically speaking, if you're going to set up a staging and a production version of a cluster, you would want to isolate out the service mesh that's associated to the staging area and to the production area so that there's no bleed through. And then changes that you introduce in this, you would test this actual configuration changes that you would make in the staging area to then reapply them in the production area to satisfy that need. They'd be two separate ones. That's the best practice standard for how you'd set it up. Typically speaking too, the containers that are targeted for each one of those areas, staging, and sometimes people put in a staging QA production environment and they promote from one to the other. That can typically be done by a repository function. There are some out there that are, marketed as a trusted registry. There are others that are just Docker Hub. You can create 3 separate hub entries, one for staging and production and QA and production. But you want to make sure that you can physically isolate one from the other and then only apply changes after they've passed tests within the staging to go to QA, within QA to go to production. So that's the general one.
So Bruce, I think what you're saying is it's probably theoretically possible to segment using a service mesh, shape traffic to the various different things, but it's not really a great practice. I think that's
that's true. Yes. Thank you. That's more succinct than I did.
Well, I got the chance to read the question again and then also listen to your answer, so I do have that advantage. But yeah, I think there may be cases like in your lower environments where you might want to share, but you lose the opportunity to test end to end, like the whole thing, make sure it's a full working system. Those trade-offs have to be made sometimes, and I think everyone has to decide for themselves, like what risk tolerance do you have, and but it does sound like it is possible to do what John is asking. So that's good, at least, right? Options are good.
Options are good.
Yeah, no, I don't have anything else coming in from the audience, but just so everybody is aware, Bruce and Mike will be happy to take questions even after the ZipChat.
Yeah, folks. Yeah, I honestly, this is what they pay me to do at the company I'm with, not necessarily to sell you anything or do any of that kind of thing, but to help you decide on technology strategies that satisfy your needs as a consumer. Because the more of you out there that are using it, the more we will probably be involved. So
yeah,
there is that in there.
And we have that white paper that if anybody wants to download it, it's somewhat related, and I'll also email out a link tomorrow with the recording and a link to that.
All right, well, I think that's it for questions. We probably kept you all long enough. Bruce, thanks again for joining us on this little casual chat. And John says his thumbs up on the answer, he understands.
Oh,
so
good.
That's all good. Sorry you couldn't interact with us directly, John, but maybe next time. So anyway, Bruce, thanks for taking the time to join us. It's been a great time for me in particular. Sonu, thanks for flipping the slides and entertaining us throughout. And Jill, of course, it's always nice to see your smile. I missed the high fives in our live events. Who knows if we'll have high fives in our live events anymore, but if we do, Jill is an expert at it, and you'll get a good woohoo from her if you do see us in person in a live event. Again, thanks to the audience for joining. I hope you had a good time. Hopefully it was informative, and I look forward to seeing you in the next ZipChat. Bye, everyone.
Thank you
all.
Bye-bye.
Bye-bye.